Hello, everyone, and welcome back to another episode with your girl, Audrey Codner-Gibson from ACG Math Tutoring. Welcome to nice, lovely, crisp fall weather. That's what I'm having right here in Baltimore, Maryland, hence the long sleeves. So we are going to get ourselves ready to do some multiplying of radicals. Hopefully you have some paper and something to write with because we're about to get started. All right, everyone, and welcome back. So we're going to be multiplying radical expressions. So we're going to look at those Common Core standards of A-APR 0.7 and A-REI 0.2. So before we do that, we're going to review the exit ticket when we were adding and subtracting radicals. So we have 5 times the square root of 3 plus the square root of 48. So remember, in order for us to add or subtract radicals, we have to have a common radical. So the radicals have to be exactly the same. So since the square root of 3 is a prime number, that we can't touch. But the square root of 48, we can actually break that bad boy down. So let's see what we can think of for that perfect prime combination. So I know if I divide that 48 by 3, I'm going to get 16. And the square root of 16 is one of those perfect square roots. So that means a number multiplied by itself will give me that 16, which is 4. And that 4 is no longer underneath the radical. But the square root of 3 that's associated with it is just going to come on down, as well as my plus sign and my 5 square root of 3. So now my radicals are exactly the same. So I can just go ahead and combine things. Now, what I can combine is basically the coefficients that's in front of my radicals. So 5 plus 4, that gives me 9. Now, the square root of 3's, since I'm adding, just comes down. So remember, when you're adding and subtracting, you're looking for numbers that has the same radical. It's almost like you're playing a matching game. So now, since that 9 is not under a radical, that's our final answer. So when I add those things, I get 9 in the square root of 3. So by the end of this lesson, you should be able to say to yourself, I can multiply radical expressions. So we're going to look at some guided notes and examples. We're definitely going to do a couple of practice problems, and then we're going to finish everything with an exit ticket. So if you are new to my channel, this is exactly what we do. Step by step, I'm going to guide you, give you a couple helpful hints so you have an understanding of what to do when you come across a situation. So for the helpful hints, first thing, the product of square roots is equal to the square root of each product. And you're probably like, say what? So if I take a look at, say, the square root of AB, and that means the square root of A times B. And A times B is the same as multiplication or products. So that means I could, if I wanted to, split them up into their own radicals. All right, so the square root of AB is equivalent to saying the square root of A times the square root of B. So for the next part, it's saying multiply a monomial, which is a 1 term, with a binomial, which is a 2 term. We're going to use the distributive property, just like you would do for a linear equation. But when you're multiplying binomials, 2 terms, you can use what's called the FOIL method, which is your first, outer, inner, last, or the box method. And I'll show you both of them, and you get to choose which one works for you. So let's get with some of the examples. When you're multiplying, you can multiply, then simplify, or you can simplify, then multiply. Let me show you what I'm talking about. So for number 1, we got the square root of 10 times the square root of 2. So if I multiply these two, I get the square root of 20. Now, the square root of 20, that can be broken down. And what will be that perfect prime combination? My perfect will be my 4, my prime will be my 5. So the square root of 4, that's a perfect square root, which gives me 2. And the square root of 5, 5 is a prime number, so it can't be broken down. So if you can't break it down, you bring it down. So that means the 2 square root of 5, or 2 radical 5, is my final answer. So what I did was I multiplied what was underneath the square roots, which are called radicands, and then I simplify it by breaking it down into its lowest terms. So what happens if I wanted to simplify first, then do the multiplication? So if I simplify first, I'm just going to rewrite over here. So I got the square root of 10 times the square root of 2. I'm going to try to break down. The square root of 2, I can't break it down, so I'm just going to bring it down. The square root of 10, I can break down into 2 things. I got my square root of 5 times the square root of 2. And since all this is multiplication, I can multiply these two. So square root of 2 times square root of 2 gives me the square root of 4. And what's the square root of 4? That gives me 2. So I have square root of 5 times 2. Now, when you come across this situation, trust me, you want to put the whole number in front of the radical. That means to the left of it. The reason why you do that, because your eyes is going to tell your brain, oh, no, that's a square root of 52. You need to break that down. When in fact, no, you don't, because it's not the square root of 52. It's 2 the square root of 5. So always put the whole number in front or to the left of your radical. So it's actually going to be 2 times the square root of 5. So no matter what, you either can multiply and then simplify, or you can simplify, then multiply. So let's take a look at number 2. So for number 2, we have our whole numbers, 3 and square root of 6 times 5 is square root of 2. You want to combine your whole numbers. So when you're multiplying, you multiply a whole number to whole number and a radical with a radical. So 3 times 5, that gives me my 15. Now this 15, I'm just going to leave it off to the side for a moment. But now the square root of 6 and the square root of 2, you can do exactly what we did with number 1. Either multiply, then simplify, or simplify, then multiply. I'm going to multiply, then simplify. So 6 times 2, that gives me 12. So the square root of 12 can be broken up to the square root of 4 and the square root of 3. Square root of 4, again, is 2. And then we got times the square root of 3. But don't forget about the 15. And we're multiplying that to the 2. So again, multiply whole numbers with whole numbers, radicals with radicals. Since we only have one radical, that's going to come on down. And then 15 times 2, that gives me 30. Okay, so multiply the whole numbers, multiply the radicals, simplify. Don't forget about the whole number to bring it on down. I feel like a temptation right now. Okay, so once you bring it on down, then again, multiply the whole number with the whole number, and then bring down your radical. So for number 3, it's just like the second tip, okay? I have a monomial, which is the square root of 3, multiplied by a binomial, which is inside my parenthesis, which is 7 minus the square root of 3. So we're going to do what's called the distributive property, just like how we did before with any kind of linear functions. So when we distribute, we're going to multiply. So I'm going to multiply the square root of 3 to everything inside the parenthesis. So it's almost like you have gum and you have like 2 friends and you have like, what, 3 pieces of gum. What, are you only going to give like a piece of gum to one of your friends and not the other? Yeah, you'll be talked about on social media. Okay, so make sure you distribute to everybody. If you got it, spread it out, spread the love. So square root of 3 times 7 gives me 7 square root of 3 minus square root of 3 times square root of 3 gives me the square root of 9. So now Square root of 3, that's prime, so I can't do anything with that. But the square root of 9, I can simplify that because that's one of those perfect square roots. So that gives me 3. Then I bring everything else down. But can I combine the 7 and the 3? No, because they're not like terms. They have to be square root of 3 with one of them and square root of 3 with the other one. So since they don't have anything and it can't be broken down, that square root of 3, that's my answer. That's it, right? So for number 4 is the second part. I'm multiplying a binomial with a binomial. So when I do this, I can do one of two ways, and I'm going to show you both ways. So the first one, I'm going to make myself a little bit of room, is called the FOIL method. Basically, you're just going to take this first term in that first parenthesis and distribute to everything in the second parenthesis. So it's going to be 4 times 2, which gives me 8. I'm going to put it over here. And 4 times a negative square root of 2. Okay, that minus sign acts as a negative. So that means I have negative 4 square root of 2. And there's nothing else to distribute, right? So now we're going to distribute this square root of 2 since it's positive. I'm going to distribute that to everything in that second parenthesis. So square root of 2 times 2 gives me a positive 2 square root of 2. And square root of 2 times a negative square root of 2. So a positive times a negative gives me a negative. Square root of 2 times square root of 2 gives me square root of 4. So now take a look right here. Right here in the dead center, you got your like terms. So all you're going to do is combine the coefficients. So the coefficients is what's to the left of the radical. So I have a negative 4 plus 2. So negative 4 plus 2, that gives me a negative 2. And then I bring down my radical 2. The 8 that's in front just comes on down. Minus comes down. But the square root of 4, that's one of those perfect square roots, which gives me 2. So now, is there anything else we can combine? Yes, we can combine the 8 and this negative 2. The sign is always to the left, okay? So it's not a negative 8, it's a positive 8 because I don't see a minus sign in front of the 8. So 8 minus 2, that gives me 6. Then I'm going to bring down my minus 2 square root of 2. Boom. That's my answer because I don't have any other like terms to combine. So that was FOIL. Now I'm going to give you the box method. So the box method depends on our dimensions. So we have a binomial, which is 2 terms, multiplied by a binomial, which is 2 terms. So I'm going to create a 2 by 2 box, meaning I'm going to have 2 rows and 2 columns. The first parenthesis, that's going to be off to the side. So I say 4, and it's a positive square root of 2. The second parenthesis will be on top. So I got a 2 minus the square root of 2. Since it's multiplication, it really doesn't matter which one goes where. I just like to be consistent. So I go from left on top. But in order to fill the boxes, I need to multiply. So to fill this first box here, I need to multiply 2 times 4, which gives me 8. To fill this box over here, I need to multiply negative square root of 2 with 4, which gives me a negative 4 square root of 2. To fill this bottom left box, I need to multiply the 2 and the square root of 2. So that gives me 2 square root of 2. And to multiply this last box, we got negative square root of 2 times 2. You're multiplying, so it's not going to be 0. It's going to be negative square root of 4. So if you notice right here in the diagonal, those are your like terms. So I start with my upper left, which is 8. Negative 4 plus 2 gives me that negative 2 square root of 2. And then my negative square root of 4 gives me minus 2, which gives me my 6 minus 2 square root of 2. You get the same answer, okay? There is a pattern going on within this, but I'm going to present that a little bit later, okay? Because if you haven't noticed, actually, let's do it now. If you haven't noticed, when we did the square root of 2 times the square root of 2, notice my final answer ended up being a 2. Because the square root of 2 times the square root of 2 gives me square root of 4. Square root of 4 is 2. For the previous one, we had the square root of 3 times the square root of 3. And that ended up being 3. Because the square root of 3 times square root of 3 gives me square root of 9. And square root of 9 gives me 3. What do you think is going to happen when I say the square root of 4 times the square root of 4? That's going to give me 4. Square root of 5 times the square root of 5. That's going to give me 5. So we can make up a rule for this right now. It's almost like a shortcut. What? So if I have like the square root of 5, if they're exactly the same, let's put it that way. If they're the exact same thing and you're multiplying, all you have to do is pull out the number that's underneath that square root. You're radicing. So if you have, say, the square root of 9 times the square root of 9, that will equal 9. Okay? So that's one of those little shortcuts that you can use, especially if you're doing any kind of testing. So what I would love for you to do is to practice. So you can either pause this video and then go ahead and solve and we can check our answers, or you can continue on and follow along with me. Totally up to you. So if I'm looking at number 1, remember, you can either multiply, then simplify, or simplify, then multiply. I like to multiply, then simplify. If I'm wrong, you like the other way, knock yourself out, see if we can get the same answer. So if you don't see a number in front of your radicand, your coefficient, it's always assumed to be a 1. So I have 2 times 1, which gives me 2. And then I multiply my square roots, which gives me 40. Square root of 40, that can be broken down into 4 and 10. And you're probably like, well, couldn't I just do 5 and 8? True, but the square root of 8 can still be broken down. You won't get the wrong answer. You'll get the same answer, but it's just giving you extra steps. So square root of 4 will give me 2. Square root of 10 really can't be broken down. Then don't forget to bring down the 2 from earlier. Multiply 2 times 2, that gives me 4, and I'm left with the square root of 10. So you're probably saying, well, Audrey, the square root of 10, that's not a perfect square, and it's not a perfect square, and it's not prime. But take a look. I'm going to put it at the very top. If I try to break down the square root of 10, I will get the square root of 5 times the square root of 2. What type of numbers is 5 and 2? They're both prime numbers. Neither one of them is perfect. So since we can't get anything out of it, you don't want to leave 2 radicals in your answer. So this is one of those special, I want to say, prime radicals that kind of floats around. So the other ones will be like the square root of 6. We know about the square root of 10, square root of 15, square root of 21. Like these are the most popular special type of prime square roots out there. Because for the 21, it's just going to give me 7 and 3. Both numbers are prime. For the 15, it's going to give me 5 and 3. Both numbers are prime. We already talked about the 10, but how about the 6? The 6 is only going to give me 3 and 2, or 2 and 3. Either way, both of them are going to be prime. So there's more, but these are the most used ones that you'll see as you go throughout the whole system, okay? Number 2, you're probably like cursing me out because you're like, we didn't do this. But I wanted to see if you remembered about exponents. So if I gave you a squared is the same as saying a times a. So that means that base is being multiplied by itself one more time or twice. So that means I can say the square root of 3 minus 2 is being multiplied by the square root of 3 minus 2. All right. So now here it should look familiar when we were doing either the FOIL or the box method. So I'll do FOIL for you. So we have the square root of 3, and we're going to multiply that to everything in the second parenthesis. So square root of 3 times square root of 3. Remember, if it's the same radical with the same radicand, the shortcut is just write what's underneath the radical. Oops, I don't know what happened here. Underneath the radical without the radical sign, because it's going to give me the square root of 9. What's the square root of 9? 3. So now we have the square root of 3 times negative 2, which gives me negative 2 radical 3. Now we're going to multiply this negative 2 to everything in that second parenthesis. So negative 2 times square root of 3 gives me a negative 2 square root of 3. And negative 2 times negative 2 gives me a positive 4. So now let's combine our like terms. So we have our 3 plus 4, which gives me 7. And then you got like terms right here in the dead center. This is not going to give you 0. The only way I can get 0 from this is if one is positive and one is negative, okay? So since they're both negative, you're basically adding it and you're keeping the sign. So that gives me negative 4 radical 3. Since everything is not like terms, this is my solution. All right? So hopefully you can basically say this. I can multiply radical expressions. Yes, you can. We reviewed the exit ticket from last time. We definitely did some guided notes and some examples, and we did 2 practice problems. So you know what? Let's get with that exit ticket. So for the exit ticket, you just have one problem, and all I want you to do is multiply. Think about what we just did. So we have 2 plus the square root of 3 times 2 minus the square root of 3. So give it a try. So next time I will have the answer key for you as usual. And I want you to continue practicing with this. Again, if you need some assistance, you got any questions, you got some comments, maybe even a suggestion like, hey, Audrey, can you please do this type of video? Write it in the comments so I can basically make the adjustments and get the videos ready for you. If you want to have more of a one-to-one with us practice with my tutoring, please contact me. Go to my website, acgmathtutoring.com, and fill out the contact form. So if anything, thank you so much for taking the time and the effort. Hopefully you're doing all right, because I feel that you are improving. So take care, and I will see you next time. Bye.